In this video, I'll talk about transformer polarity, subtractive versus additive, the two common polarities in transformers. So if we look at IEEE 57.12.00-2015, single phase, because polarity only applies when you're talking either single phase or one phase of a three-phase transformer. So you're talking about one phase at a time. Three phase, we talk about phase, angle, displacement. It's a separate thing. But when you have single phase transformers that are rated 200 kVA and below, and the winding voltage, 8,660 volts and below, those they have to be additive. It's just a standard. So in other words, so if you have a single phase transformer, and it's 200 kVA and smaller, and also the winding voltage is 600 volts and smaller, that's where additive, they must be additive. And the reason being is just for standardizing, that's really why. Otherwise, if some of them are additive, others are subtractive, it can cause confusion, and we will see why, like the importance of polarity, like why you should pay attention to it. So all other single phase transformers shall have subtractive. So in other words, if they're single phase, greater than 200 kVA, greater than 8,660 volts, those they need to be subtractive. They need to have subtractive polarity. So when we look at polarity itself, it really has no impact on the internal voltage. In other words, if I take a high voltage, for instance, winding, and I take low voltage winding, and these are wound around the same core, so core, really polarity has no impact on the voltage that occurs from here to here and from here to here, for instance. Polarity only matters when it comes to external terminals, as we'll see. So I'll start with subtractive polarity. So let's assume, just as a simple example, we have a single phase and the ratio between high voltage and low voltage is 2:1. In other words, if you take high voltage divided by low voltage, so that's a ratio of 10. Now, if you look at it so this is tank, for instance, and these are bushings, H1. So H1, for instance, is the hot or the line connected to the line, and H2 would be the neutral. Then you have X1, X2, so single phase transformer. And the windings, if you look at them, so you have H1, H2, X1, X2. Then, so let's assume we have this connection. Then if you want to know what the polarity is, subtractive versus additive, one way you can do it, you can connect H1 to the adjacent low voltage. So if you take H1, the adjacent terminal is X1. So that's what you see here. So we are connecting H1. So this is a wire, basically a conductor or a jumper, to tie the two together. Then connect a voltmeter across the other two terminals. So basically H2 and X2. So that's, you see, this is a voltmeter. So step 1, 2, connect a source between H1 and H2. In other words, energize the high side. You always want to, when you are applying voltage, like for testing, like a ratio, as I explained in a previous video, it's better to apply to the high voltage, because that way the voltage that will be induced on low voltage is small. But if you apply the voltage to the low voltage side, that voltage will be stepped up, and it could reach a high level that can cause safety concerns, like to the personnel or equipment, or so. But anyway, so this is a source. So we're assuming we're applying 120 volt AC. So this is AC, so between H1 and H2. In other words, 120 volt is applied here. Then the voltmeter would read the difference between the high voltage and low voltage, because 120 with a ratio of 10, it will be 12 volts here, because it's a step down in this case. So what I'm showing the dot side here for this winding here. You can think of the dot, for instance, as a positive. Like if you take, since it's AC, it will be sinusoidal. So basically the dot or the plus, you can think of it this way from here to here, like when it's positive, basically, because the top side is positive, the bottom side is negative. It's just a way kind of help understand. Then if you do KVL, if you go around, because if you go from here to here, from H2 to H1, so that's negative 120. Then you go, these two are tied. Then here it's plus 12 volts. Then minus V equals 0. That means V I think I got the signs wrong, but what the voltmeter would read is basically 120 minus 12. So the difference. So you can do KVL and actually, if you do KVL, so if you start from, let's see, if you start from H2 to H1, so that's negative 120, then here it's positive, you're going from positive to negative, so plus 12 plus V equals 0. That means V equal 120 minus 12, which is 108 volts. So the voltmeter will read a voltage that's smaller than what's applied. So this is subtractive. So subtractive because the voltage that's read by the voltmeter is smaller than the input voltage. Now if we take the same circuit, except what I'm showing here, this coil, the dot is on this side, the dot on this side, and I'll explain what the dot means. And I do the same thing, follow kind of the same thing. So jumper H1 to, in this case, X2, because X2 is kind of adjacent to H1. Then I apply 120 volt. It will be 12. So if you do KVL, so again, negative 120, negative 12, because I'm going for a negative to plus this time, negative plus V equals 0. That means V will be 132 volts. So the voltmeter reads a voltage that's greater than what was put in. So in this case, it's additive. In other words, it added the voltage of the high voltage and the voltage of the low voltage. Subtractive, it did the subtraction between the voltage of the high voltage winding and low voltage. So when does subtractive additive polarity matter? As I stated at the beginning, polarity really has no impact on the voltage, internal voltage, of the windings. But it matters in certain cases. So as we saw from here, it depends on how you arrange the windings. So like subtractive, basically, as I will explain, what that means, this coil here, the high voltage, is wound, say from the dot to the non-dot in that direction. The same thing here from the dot to non-dot. So if you take the lead, let's say I call this the lead that's dotted, I call that start. I start from there, then I finish here. The same thing here, start, finish. That means these two coils are wound in the same direction with respect to the core. Now here is the opposite. So if this is start, finish, if where I started is the start and I marked it with a dot, that means start is here and finish here. So going in this direction, this one is going in the opposite. So it matters how you bring the leads out. Then what is the impact on that? We saw from subtractive, the two adjacent voltages, leads, high voltage and low voltage. So in this case, H2 and X2, the voltage across them was the subtraction. In the additive, it was actually the sum of the two voltages, high voltage winding and low voltage winding. So if two adjacent leads, one high voltage and one low voltage, like I was kind of showing, H1, H2. So let's take subtractive X2, X1, X2. So that means dot here. The dot just signifies the direction of the winding. Now, if somehow accidentally, something happens and this lead becomes connected to this lead, so there will be a very large voltage, if this lead H1 somehow becomes connected to X1, then the voltage between H2 and X2 will be the difference between the high voltage winding and low voltage winding voltages. If it's additive, it will be the sum of the two. So that's one difference between subtractive and additive. So this can be significant when both windings have very high voltages. As an example, this winding is 200 kV, this one is 80 kV, just as an example. Well, in this case, this is subtractive. So this is subtractive. So if somehow H1 becomes connected to X1, then the voltage from here to here will reach 280 kV. So if the insulation is not designed for that, then that can be a problem. No, I should take that back. In this case, it's 200 minus 80, which is 120 kV. But if it's additive, H1, H2, X2, and X1 is so the dot is on this side. Now, 200 kV applied here, 80 kV. Somehow H1 becomes connected to X2, like something accidentally connects to them. Now this voltage here between here and here will be 280 kV. So you can see 280 kV versus 120. That's like a difference of 160 kV. So that's one difference between subtractive and additive. That's why the standards kind of limited the additive polarity to 8,660 volts. So this can have an impact on the electrical clearance between the adjacent leads. In other words, in this case, H2 and X1 or H2 X2. So if it's additive, that's what it has more impact, because the two leads will see a voltage that's the sum of the high voltage and low voltage windings. So in the case of subtractive polarity, the voltage across the other adjacent leads will be the difference between the high and low voltage. If it's additive, it will be the sum. So polarity provides information on the direction of two coils that are wound, as well as the terminals that are taken to the tank. So two coils can be wound in the same direction. Sometimes we say direction or sense, like the way they were wound with respect to the core. So for simplicity, let's assume core form, because it's kind of simpler. The coils are concentric. In other words, you have the core, then the low voltage is wound around the core leg, then the high voltage on top of the low voltage, and so on and so forth. But so if you take these coils, if you look at the high voltage, for instance, let's get a highlighter. So if you follow the high voltage here, so you see it kind of goes over the core, then under. If you look at the low voltage, it's the same direction. It goes over, then under. So they are wound in the same direction. The way we signify that is by this dot here. The dot, really what it means is these two coils are wound in this is the direction of these two coils. So if I take the same coil here, so you see the high voltage is kind of goes over, then under. Low voltage, all I did here was, let's see, like in this case here, you see X1 terminal is kind of goes over. All I did, instead of over, I took it to this side, such that instead of showing to the left, it's to the right. So the only thing I changed is, so the two coils are wound in the same direction. The only difference is the X1 and X2 terminals are kind of like swapped. So when you look at them on top of the tank, you will see, if you are standing in front of the high voltage, you will see from right to left, you will see H1, H2, then you will see X1, X2. In other words, X1 is kind of adjacent to H1. Versus here, you will see actually X2 is next to H1. So this is subtractive. This is additive. So what's the difference? You see the coils are wound in the same direction, and the terminals are kind of taken out in the same place, basically. H1, X1. So if you call this start, for instance, like where the dot is, that's the start of the coil. Then you kind of wind the coil, and you call the end of it is the finish, just as to make it kind of, let's put start here. So you start from here, you wind, and you finish at H2. The same thing here. You start winding low voltage coil at the start, you finish right here. So we'll call this start H, F, or finish H, high voltage basically. Let's just write HV, start LV, finish LV. So you see these starts are taken at the same place if you look at it from the tank. So what you will see in the subtractive, if this is the top of the tank cover, so if we assume this is the winding, you will see H1 bushing here, H2 here, then the low voltage, you will see X1, X2. In other words, so since here, just for simplicity, I call it start, then I call this the start. So start of high voltage, start of low voltage, then the finish will be on the same side, finish of HV, finish of LV. For the additive, what you will see, so again, the same thing here. So you will still see H1, H2, but this time you will see X2, X1. So again, if this is the start of high voltage, this is the start of low voltage. So they're kind of like 180 degrees from one another. So polarity, basically, you look at the coils, the coils, high voltage or low voltage, they can be wound in the same direction, but the way you take the terminal leads, H1, H2, X1, X2, out to the tank cover, that's what will determine subtractive versus additive. So sometimes people will put a dot, basically a dot. They might put a plus or just an X. So it depends on what you are looking, what book or textbook or paper you're reading. So the dot mark means two coils are wound in the same direction relative to the core. And what do I mean? So if you take, for instance, if this is the mandrel, basically that they use to, then you have the kind of the shaft, and the machine will be spinning the mandrel. Let's assume the wire is kind of coming from here. So this is the wire or conductor. Let's assume the machine spins this way, counterclockwise. As the machine spins, the wire will go in this direction. So if you take high voltage, low voltage, that's how you kind of determine the direction of the sense of winding the coils. So we know the same flux induces the primary and secondary voltage because they are wound around the same core. So the same flux will try to link both windings. So this voltage that gets induced will be in the same direction in each turn. The induced voltage will also be in the same coil direction or sense. That's another reason for showing or another meaning of the dot. So in other words, voltage will be from the dot. For instance, if we take the dot as the positive, like in the half positive cycle, from here to here positive, that means in the low voltage is the same thing, because you will have the induced voltage will be in the same direction. So polarity is important for various reasons. One, if you are going to parallel transformers, you want to make sure they're connected the right way. Connecting transformers in banks, so you have 3 single-phase transformers, and you want to connect them as a 3-phase bank. So you want to know which leads to connect to which to make up, the Y, delta, and so on and so forth. And also, as we saw, voltage between two adjacent leads or adjacent terminals, one high and one low voltage, would be the sum of winding voltages for additive polarities and their difference for subtractive polarity. So that's another thing you want to keep in mind, because the two, if somehow one high voltage and the next low voltage or adjacent to it become connected for some reason, then the other two terminals, high voltage, low voltage, they have to be, for additive, you have to insulate them for that voltage, which is the sum of the high voltage and low voltage. All right, thank you.